All right, so here we go. So 5.3c. So before we get to number 1b, a couple general comments. One, I want to remind you about problem-solving strategies. Okay? 1, draw the path of the projectile. Okay? 2, draw vector triangles for any points that are important in the motion. All right? In terms of equations, horizontally, this is the only equation you should ever use. Okay? Because your horizontal velocity is constant. So the horizontal displacement is equal to that horizontal velocity times time. All right? Yeah, sure. Vertically. So this is where most of the work comes in, is dealing with the vertical stuff. Because your vertical velocity is what changes as your object flies through the air. All right, so vertically, you've got 4 equations to work with. And I'll just leave these up on the board as we're going through stuff. I guess I should have written them on the board over here. These are in no particular order. And cool. All right, and the only time you will put just like a straight out velocity into an equation is if you're dealing with one of the vector triangles, which I will do right here. So V, either VI or VF, here's your VX, and then here's your VIY or VFY, depending on what your hypotenuse was, right? So this triangle right here is the only time you will ever use this V. Does that make sense? Okay, so if the problem says Evel Knievel goes off a jump at some weird angle at 40 meters a second, that 40 meters a second will never go into an equation. Okay, what you'll put into the equation is either the Vx or the Vy. Make sense? All right, so that's a quick overview. Does anybody have any other sort of just general questions before we dive into solving a problem? We're good? Okay, so here we go then. Let's do number 1b. So number 1b, this is that weird chips problem, which is a terrible police drama from the 80s. Drama might be a strong word. So it says that one of the guys, either John or Ponch, goes off of a jump at 27 meters a second, and the jump is angled at 60 degrees. Okay, so you should make a little drawing like this. Oh, he's going initially off of a jump at 27 meters a second. Oh, the jump is inclined at 60 degrees. So what should you do right away, you guys? Draw in your vector triangle, right? So here's the x component of that velocity. Does everybody agree we can just do some quick trig and figure that out? So that gives you 13.5 meters a second. Okay? There's also a vertical component. So his velocity initially in a vertical direction is, this side of the triangle, and it turns out to be about 23.4 meters a second. So are there any problems on how I got all of that information? Good. All right, so that's a safe bet for your first step. Okay? The next thing I would say is draw the path that they follow, or that the dude follows when he's going through the air. So his path is going to look something like this. Okay? And everything that I just drew here inside this yellow box corresponds to the velocity at that point. Does that make sense? All right. Now, the problem also says something about 66 meters. It says it's 66 meters to the other side of the bridge or something like that. So, is that the displacement? What do you guys think? Can I use that as my delta x? A couple of you guys are shaking your head. How come, Lucas?
Because it's not necessarily how far the person goes, it's just how the gap that they would have to cross.
Good, yeah. The idea is, for him to successfully make the jump, what we need our delta x to be bigger than that gap, right? Does that make sense? Right? If you've got the two ends of the drawbridge and they're 66 meters apart, then for him to clear it, he's got to jump farther than that, right? So what we're going to do is we're going to find the delta x, and hopefully it'll be more than 66 meters, right? Does that make sense or no? Okay.
Was that initial question you asked, or was no? The answer was no, too?
I don't think so.
No, he's asking, what was the initial question you asked?
Oh, I'm sorry. I asked if the 66 meters was the displacement.
Oh, it's just like how far they are.
Right. It's how far he needs to go. Gotcha. And I misheard your question, so we're even. All right. Is everybody good? Okay. Now, question A says, how long does it take him to reach the peak of his path? So question A wants to know how long it takes him to get to that pink dot. All right? So in the same way that I wrote out everything I know for the yellow dot, right, everything initially I wrote here, let's figure out everything we know about that top point. So at that peak, what do we know? I know a few things about what's happening at this pink dot.
Vy equals 0.
Good. Vy is 0, right? Because when you're at the top of the path, your velocity vertically is 0. Okay. Would it be wrong to call that Vfy? That'd be okay. Sure. I guess it depends on your time interval, but it's not wrong. Okay, what else?
No, horizontal is.
Good. We know the horizontal is still 13.5 meters a second. What's the overall velocity? Same thing, right? Because all of your motion is horizontal, right? There's no vertical motion. You good, LaShawn? No? Are you good with why I made that the velocity? Everybody good? Yeah?
With the acceleration, be negative 9.1.
Yep, and that's actually true the entire time. So I kind of, here, let's write it over here, because this is always true. I wish I had written it in blue. Okay, good. All right, so everything that I just wrote in this corresponds with this pink point, right? Now what we're trying to find is the time that it takes to get from the yellow dot to the pink dot, right? So I need to find an equation. So, option 1. I always tell you to start with the horizontal information. Does this help me find the time to the peak? Well, in order to find the time to the peak, I'd need to know my Vx, which we know. But I'd also have to know my delta x. I'd have to know how far he went horizontally by the time he reached the peak. Do we know that? No, we don't know that, do we? Okay, so this equation's not going to help me any, right? Follow? All right, so the only other option then is to look at the vertical information. So to find the time that it takes to get to the peak, I got to pick one of these equations. So I can't use any of the ones that have delta y, because I don't know my delta y, right? So there's only one possibility. What's the only equation that'll help me, guys? The first one, right? Okay, so let's do that. So for that pink time interval, here for this time interval, here's what I know. I know my VIY is 23.4. I know my VFY is 0. I know my AY is negative 9.8. And I'm looking for time, right? You guys agree that I can use, I don't want to write on my, that I can use this top equation? Cool, and plug everything in, and you find your time. It turns out to be, I think it's 2.37, 2.39. Make sense, you guys? What was that? Maybe it was the snow day fairy. Maybe go look. What's all that noise? All right. All right. Are we good? All right. Does everybody kind of understand this process? It's very similar to Chapter 1, but just more garbage to keep track of, right? Okay. All right. So that's part A. Are we good with it? All right, part B says how long are they in the air total, or how long are they in the air before they return to their original height. So now I'm looking for the amount of time it takes to get to, oh, that's terrible. Looking for the amount of time it takes to get there, right? So how do I find it in one step? Multiply it by 2, right? If it takes 2 seconds to go up, it's going to take another 2 to come down for a total of 4 point whatever. So that's part B. Cool? All right, part C. How far do they go horizontally? So part C wants to know, bless you, part C wants to know this displacement. Right? How far do they go horizontally, right?
Yeah.
So to find my displacement total, I'm going to use my Vx and multiply it by my t. Which time, you guys? Total, right? If I want to find out how far they go while they're in the air, I'm going to multiply by the time they're in the air. So the Vx is 13.5 meters a second, right? That's how fast they're going horizontally. And they're in the air for, what did we say? 2.39 times 2. Oh, I never wrote it down. What is it? 4.78? Okay, and it gives you like 64 meters. Hooray! Sort of. So hooray, because we got an answer. Are the questions with how I got it? Question D is why I said sort of. Question D says, will they make it? Or will he make it across? No. Because for him to make it, he had to go 66 meters. And he only went 64, so he missed it by 2 meters. Good?
Wait, so it's, if it was 66, then it's yes?
Sure. I mean, yeah, that's like, he's right on the cusp, so, you know. But all right, are we good? Okay, Roman numeral 5 wants to know the velocity after 3 seconds. So Roman numeral 5. So at t equals 3 seconds, find Vf. Now here's the common mistake. Can I just do this and be done?
No.
No. This is a linear motion equation. It only works for linear motion. All right? This chapter, the equivalent would be this. Can I just do that and be done? No. Okay, because all this does is it gives me the vertical velocity after 3 seconds. All right? Think back to day 1 of this chapter. How do we fill in the V column on that chart, you guys? Pythagorean theorem, right? So in order to find a velocity at the end of some time, I need to think about my whole triangle. So what I know is, at the end of 3 seconds, I know my Vx is 13.5 meters a second. But I need to find my VFY. So let's see. VFY is VIY, which is 23.4, plus AY, which is negative 9.8 times 3. So my VFY is negative 6 meters a second. What does it mean that the VFY is negative, you guys? It's coming back down. Does it make sense that after 3 seconds he'd be coming down?
Yeah,
Yes.
Yeah, because after the top is only 2.3 seconds, so he's past it. You okay, Ray? What are you doing? You look like you're trying to send a message to somebody. Oh, gotcha. All right, everybody good up to there? All right, so now we just draw our triangle, right? So we go, oh, at this instant, my Vx is 13.5. My Vy is negative 6. And I'm looking for V. Follow? So Pythagorean theorem will get me the hypotenuse. Then am I done?
Yes.
Not quite. You got to find the direction, right? Remember, velocity is speed and direction. So anytime I ask you for velocity, you got to give me the direction. Okay? So Pythagorean theorem gets us the hypotenuse, and some simple trig will give us this angle here. Okay? And the answer is on the sheet. So, follow? Well, Sean, how are you doing back there? You were the one that said you wanted me to start at the beginning. Is this making sense, or?
Mm-hmm.
All right. Problems, you guys? All right, so one last part. So Roman numeral V, I wants to know, when he's 20 meters up, what's the velocity? So 20 meters up, what am I telling you there, you guys?
The displacement.
Displacement, sort of, which kind? Vertical, right? And I want to know my VF at that instant, right? So the idea is, he goes flying through the air. There's going to be a point in here somewhere where his vertical displacement is 20 meters. And at that point, I want to know what his velocity is, right? What do you notice, though? There's something sort of weird about this drawing. That's the same displacement, isn't it? So there's two answers, right? He's going to hit that height twice, once on the way up and then once again on the way down, right? Cool? All right, so let's focus on one of these time intervals. Let's do this one. So for that red time interval that I just drew, here are the things I know. I know VIY is 23.4. I know delta y is 20 meters. I know AY is negative 9.8 meters a second squared. All right? To find the velocity at a point, remember, I need to know my x and y components, right? Follow? So I already know my x component here, right? So if I can somehow find my y component, then I'm in good shape, right? Does that train of thought make sense or no? Find the y component at that instant, and then I can just do Pythagorean theorem again, just like I did wherever it is. Right here, right? Okay? So, does anybody see an equation I can use using these four variables to find VFY? Oh, darn it, that's not what I wanted to do. You stay there. Oh, it won't let me do that, will it? No, it won't. Okay. One of these equations, though, I think will work, right? Can't we use this guy to find our VFY? So notice when you solve this, you're going to have to take a square root, right? What's the square root of 9, you guys? Plus or minus 3. So when I solve for my VFY, I'm going to take a square root, and I'm going to get VFY equals plus or minus 12.4. Why plus or minus, you guys? One's on the way up, one's on the way down. These are two answers, right? So then draw your two triangles and find your hypotenuses. Hypotenuses. Hypotenusi. Hypotenuses. Okay, I'm done with that game. All right, are there questions about what we did here? Okay, so to me, that's kind of the basics. I think we hit a lot of stuff there, all right? Outside of that, it just becomes, what do I know? How can I use what I know to solve the problems? All right? Please be careful about your time intervals, okay? If it's asking you how high it goes, you want to use TP, right? If it's asking you how far it goes, you want to use T total, right? So watch out for that kind of stuff. I'm sure people had questions on other ones, but I think I really want to fit this target check in. I wish we could push the test back, but there just isn't time for us to do that and still get through energy before the end of the semester. General questions? Yeah?
Are we going to have another test before break?
No. Well, you're going to have one on Thursday, but after that, no. We're going to do one more test after break.
Wait, next week's our last week, right?
Yeah. Okay. Yeah, I know. Yeah, the end of this second card marking is way shorter than the first. All right. So, here's what I'm going to do. I'm going to pass out a target check. If you finish it, awesome. If not, take it home. Finish it on your own, please. And get it to me tomorrow morning-ish, sometime, like before lunch if you can. And I'll try to get it graded before I see you 6th hour, okay? Is that okay? I really wish we had like one more day, but we don't, so it is what it is. All right? Clear? Okie dokie. Bless you.
Thank you.
Twice, I think.
Yeah.
Were there 2 sneezes there? My counting skills are exceptional. I don't remember. There was something there that got erased. It's old now. Oh, hey, how are you? Thank you. Yeah, no, thank you. I'm glad you gave that to me. I forgot. Joey, remind me to say a thing when I'm done passing these out. John, make sure Joey remembers to remind me to tell me the thing. Say the thing. I don't think you will. John just looked sad that I didn't ask him. Oh, did I count wrong? Oh, got it? Oh. You do need one?
Question.
What? Oh, right. Joey just reminded me that I needed to say a thing. Hey guys, on problem number 2, just to clarify, it says a soccer ball is kicked from a horizontal field at a velocity of 20 meters a second after being in the air for blah, 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 blah. So it's the field is horizontal. The ball is being kicked up off of the horizontal field into the air. So it's going to both start and land on the same horizontal surface, just like if you were kicking a ball on a soccer field. Okay? So if you wanted a drawing, it would look like this. Okay, it's being kicked, the field is horizontal, it's being kicked up like that. Good? You just don't know the angle it's kicked at, which is part of the issue. Okay, good luck. Holler if you need anything clarified. While you guys do that, I'm going to pass back your last lab after I take attendance. Ooh, I forgot to hit pause. I'm still recording.